So now let's go to applications to word problems. Now this time, I'm assuming that you already know how to find the areas under the normal curve. So problem number 1. The average Pag-ibig salary loan for RFS Pharmacy Incorporated employees is 23,000. If the debt is normally distributed with a standard deviation of 2,500, find the probability that the employee owes less than 18,500. So we're given with the mean. So this is the mean and this is the standard deviation. So we are asked to find the probability that the employee, so the employee owes less than, so less than 18,500. So we will transform this one into the standard normal distribution. So we will transform x to z. So we will convert this one using the formula x minus mu over the standard deviation. So therefore, this is equal to z less than. Our x here is the 18,500 because that is the one we need to convert. And then minus our mean, which is 23,000. So divide by the standard deviation, 2,500. So using your calculator, we have negative 1.8. P, Z, the probability of Z less than negative 1.8. Okay, so meaning we have negative 1.8. So if we draw this curve, so we have the mean, which is 0. The negative 1.8 is on the left side. And then, of course, since this is less than, so the shade is here on the left. So this is less than, so the shaded part is on the left side. So let's find the negative 1.8 on the table. So since this is symmetric, so we can just look at 1.8. So 1.80. So we have 4641. But since this area here are from the center, it means that this 0.4641 is the area on this part, the unshaded part, no? So this one, this is the 0.4641. So meaning the area to the left, or the shaded region, can be solved by doing this. The whole area to the left is 0.5 minus this area, which is 0.4641. So if we subtract 0.4641, this area, from the whole one side, which is 0.5, we're left with this one, with the shaded region, right? So we have 0.5 minus 0.4641. So the result is 0.0359. Okay, 0.0359. So the probability that the employee of this pharmacy owes less than 18,500 is very small. It's just 0.0359. Number 2. The average age of bank managers is 40 years or 40 years old. Assume the variable is normally distributed. If the standard deviation is 5, find the probability that the age of a randomly selected bank manager will be in the range between 35 and 46. So we're given with the average 40 and standard deviation of 5. So we're asked to find the probability that the randomly selected bank manager will be in the range. So between 35 and 46. So again, we will convert this one to z. So on the left side, we have 35 minus 40 over the standard deviation 5. And on the right side, we have 46 minus 40 over 5. Okay. So we have here on the left side, this is negative 5 over 5, so negative 1 or negative 1.00. On the right side, it's 6 over 5 or 1.2. Okay. So if we draw that one on a normal curve, we have 0. We have negative 1 on the left, and we have 1.2 on the right. So if you notice, the z is here. The shaded region is here. It crosses the 0 or the center. So since this area here are from the center, we can just add the areas of this side and this side. Okay, so 1.0, the area for 1.0 is 0.3413. So we have 0.3413 plus, and the area of 1.2 is 3849. 0.3849. So use your calculator to add these two numbers. Plus 0.3849. 7262. So therefore, the probability that the age of randomly selected bank manager will be in the range 35 and 46 years old, or between 35 and 36 years old, is 0.7262. So there's a bigger chance that the age is really between 35 and 46 years old. Number 3. A company produces different types of energy drinks. The filling machines are adjusted to pour 500 ml of energy drinks into each plastic bottle. Nonetheless, the actual amount of energy drink poured into each bottle is not exactly 500 ml. It varies from bottle to bottle. It has been observed that the amount of energy drink bottle is normally distributed with a mean. So we're given with this mean of 500 ml and a standard deviation of 4.75 ml. What percentage of the energy drink bottles contains 505 to 513 ml? So we are asked to find this probability. So contains, so less than or equal, because it can also hold 505 ml. On the right, we have 513. So we'll convert this again to z using the same formula. So this is 505 minus the mean is 500 over 4.75. On the right side, we have 513 minus 500 over 4.75. So this is equal to positive 1.05, and the other one is 2.74. Okay, so both of them are on the right side of the normal curve. So if we draw the normal curve, so we have 0, you have the first z here, 1.05, and the other one is 2.74. So this is the area or the probability that we need. So in this case, both of them are on the right side. So our strategy here is subtraction. So we'll start first with the z, which is farther from 0. So we have 2.74. The area of 2.74 minus the area of 1.05, we're left with the shaded region. So 2.74. So 2.7 is here. We have 4. So we have 4969. Okay, it's 4969 minus the 1.05. So 1.0 is here, 5 is here. So we have 3531. So let's subtract. So the result is 0.1438. Okay, but the question is what percentage? So the final result for this is we'll just multiply this one by 100%. So our final answer is 14.38%. So 14.38% of the energy drink bottles contains 505 to 513 ml. Next, number 4. Consider the investment in stock market whose return is normally distributed with a mean of 20% and a standard deviation of 8%. Determine the probability of earning money. Okay, so when we talk about money, when we earn money, it's of course greater than 0 because it means we're now earning our money. So we'll just have this, convert again that to z. So that's greater than. So 0 minus the mean is 20. So the percent there's a problem, it's just is its unit. So 8. So we have negative 2.5 or 2.50. Okay, so negative, so greater than. So if we draw that's a normal curve. Negative 2.5 is here on the left side. So greater than, so the whole right side of the 2.5. So it means the whole right side, this part of the normal curve is covered, which is 0.5, right? So we already have 0.5. And we're left with this small area here, which is negative 2.5. So we will look at negative 2.50. So we have here 0.4938. So plus 0.4938. So this is now 0.39. 0.9938. So the probability of earning money with this investment is very high. It's almost 100%. Number 5. The average daily jail population in the new Bilibid prison in Muntinlupa City is 36,295. If the distribution is normal and the standard deviation is 3,760, find the probability that a randomly selected day the jail population is greater than 40,145. So we're given with the mean and the standard deviation. So we're asked to find the probability that on a given selected day, the daily population is greater than 40,145. So again, we'll convert this to Z. So 40,145 minus the mean, which is 36295, divided by the standard deviation of 3760. So use your calculator. 3760. So this is approximately rounded off to 1.02. So the probability here is Z greater than 1.02. So if you draw the normal curve, we have 0. The 1.02 is here. So greater than it's on the right. So by just looking at this, it means that the half of the curve is not whole. So an area must be subtracted from 0.5 to get the remaining area. So 0.5, the whole area on the right, minus 1.2. 3849. No, it's not 1.2, sorry, it's 1.02. So 1.0 is here, 0.02 is here on top, so we have 3461. So 0.3461. So subtract. So we have 0.01539. So the probability that on the given or a randomly selected day that the jail population is greater than 40,145 is 0.1539. So the probability is very small, or it's small. Number 6, the average credit card debt for a public school teacher is 14,975. If the debt is normally distributed with a standard deviation of 5,650, find the following probabilities. Letter A, find the probabilities that the teacher owes at least 6,740. So we're given with the mean and the standard deviation. When we say at least, it means greater than or equal. So that is our symbol, inequality symbol. So again, convert this to Z. So we have 6,740 minus the mean, which is 14,975, divided by 5,650. So what is this equal to? Z greater than or equal. So 6,740 minus 14,975, and then divide this by 5,650. So negative 1.46. Okay. So visually, when we draw this normal curve, we have 0. We have negative on the left of 0, 1.46. Our inequality symbol is greater than or equal, so it's to the right. So we have this. Okay. So if you notice, the whole right side of the normal curve is covered. So we have already 0.5. Then we will add this remaining area. So we have 0.5 plus, what is 1.4? Okay, 0.4192. 1.46, I mean, sorry. It's 1.46. So this is 1.4, this is 6. 4279. 4279. So this is now equal to 0.9279. Next, find the probability that the teacher owes more than 19,270. So more than, so again, that's greater than 270. So convert that one to Z. So 19,270 minus the mean, 14,975, over the standard deviation, 5,650. $19,270 minus 14,975 divided by 5,650. 0.76. Okay, so greater than 0.76. So let's draw the normal curve. We have 0. Then we have the 0.76. It's positive. Okay, and our inequality is greater than, so we have this. So visually, it's 0.5, the half of the curve, minus this area. So 1.76. Let's find 0.76. So 0.7. Then we have 6 here. So we have 2764. So 0.2764. 0.5 minus 0.2764 is 2236. So 0.2236. And last, between 6740 and 19,270. So this is 6740 and 19,270. So if you notice, these two were already converted. So 0.6740, that is negative 1.46, and the other one is 0.76. So this is negative 1.46, and the other one is 0.76. So let's draw the normal curve. So 0. Here is the negative 1.46 on the left, or at the left. Then we have 0.76 at the right. So it means we will add the respective areas of the negative 1.46. So 1.46. So we have 4279. Plus our 0.76, 2764. 0.4279 plus 0.42 2764 7043. So the probability that a teacher owes between 6,740 and 19,270 is 0.743.